Hello friends, today myself Dr. Suhas Siddeshwar going to talk about gastro-retentive drug delivery system today. So before starting the session, we can observe this diagram which is there on screen and can see why we have to retain the particular dosage form in this stomach region. So first of all, we will discuss what is the meaning of this term gastro-retentive drug delivery system. We should know drug delivery system means we are preparing some dosage form to deliver drug. And gastro-retentive means gastro, this term is specially used here for stomach region. So idea is very clear. We have to retain our dosage form in the stomach region. Gastro-retentive. Retentive means we have to keep, we have to withstand our drug in the gastric region, means especially in the stomach. So in this entire presentation, we are going to discuss on introduction, advantages, what are the various gastro-retentive technologies, and some evolution part. So in introductory part, what is necessity of gastro-retention? So first point is gastric residence time. We are improving gastric residence time of our dosage form. Second point is important, since the majority of drugs are absorbed in stomach or the upper part of the small intestine. Because of this, we have to retain our dosage form in the stomach region. These are the two important considerations while designing the gastro-retentive dosage form. So various approaches have been proposed to increase gastric residence. So there are various approaches which we are going to discuss in further slides. But here you might have heard the term floating tablet. Floating means what? We are floating our tablet or our dosage form in the gastric fluid. So that is called as floating drug delivery. So in nutshell, how we can explain this? Gastro-retentive delivery is one of the site-specific delivery. Why site-specific? Because we are specially targeting on the gastric part, that is the stomach. Therefore, it's called as site-specific, right? And here we can prepare the dosage form in controlled manner or sustained manner. So both way we can work this. Okay. So gastro-retentive drug delivery is a site-specific drug delivery of drugs at stomach. Here we have to remember this. So what is basic difference between this conventional and gastro-retentive? So here in gastro-retentive, the main part which we are highlighting is the stomach as well as upper part of the intestine. Here we have to understand. Okay. So what are various advantages of this? So very first is narrow absorption window. So to which narrow absorption window means what? So those drugs absorbed from specific region, mostly first part of GI tract, they are called as narrow absorption window. Narrow means what? Specific. And what is specific region? That is the first part of GI tract. Second is longer residence time in the stomach could be advantageous for local action. In case of peptic ulcer, the peptic ulcer is this disease is specially for the stomach, and we can give this drug delivery to the local diseases like peptic ulcer, and this dosage form will show local action. Third is viability can be improved. Viability can be improved means we are keeping our dosage form in the stomach region. Therefore, the final output is increase in viability. Then next is reduce frequency of dosing with improved patient compliance. Yes, because we can reduce the frequency. If we are taking 3 tablets per day, we can reduce the dose, we can prepare control release, and we can reside that dosage form in the stomach region. Then minimize the fluctuation of drug concentration. fluctuation can be minimized. Size specific, because we are targeting especially the part stomach region, and enhance pharmacological effect. So these are some advantages of this. Now next slide is, what are the suitable candidates for this gastro-retentive drug delivery system? So very first is drugs acting locally in the stomach, for example antacid. So these are the very good candidates for GRDDS. Second, drugs that are principally absorbed in the stomach. Yes, if they are absorbing in intestine, the late part or the end part of intestine, then they are not suitable for this GRDDS. Then poorly soluble at alkaline pH. They are also not good candidate for this GRDDS. Then drugs with a narrow window of absorption, for example furosemide, right? So drugs with narrow window of absorption, they are candidates for this GRDDS. Next is drug absorbed readily from the GI. If the drug is not absorbed through GI tract, then they are not good candidate for this GRDDS. Then drugs that degrade in colon, they are also not good candidates for this gastro-retentive drug delivery system. Then variable viability, drugs with variable viability requires drugs with a less half-life. These are some uh, uh, candidates requirement for this gastro-retentive drug delivery system. Now the various technologies. This is very important part. How now I want to retain my dosage form in the stomach region. So what are the various approaches for that? So non-effervescent systems, effervescent systems. This is the main category. Under effervescent systems, low density system, that is floating, swellable, that is expandable system, then mucoadhesive system, and high density system. So effervescent and non-effervescent, we know the difference. Where with the help of acid and base reaction, once they will come in contact with water, CO2 will release, and this CO2 will help to disintegrate the particular tablet. They will convert into the small pieces. This is the effervescent system we know. So how now this technology we are going to use for different approaches? So very first, this is the structure of stomach we know. The structure of stomach is what? Fundus, then esophagus, then this major part, right? Body, then pyloric sphincter. You can see here pyloric sphincter, and this last part is pyloric antrum. So if you see carefully, this four approaches we can use have been defined here. So first is the floating system. We have to float our dosage form on this fluid, gastric fluid. Second is bioadhesive system. So bioadhesive system, our dosage form we have to stick on the wall of the stomach. Third is swellable system. We have to swell our system or dosage form like that it should not go, or it should not cross the pyloric sphincter, right? So these are some important approaches. And last is high density system. How it works? If we'll increase the density of our system, it will settle in this pyloric antrum, and likewise the drug will release slowly. So this is in view picturization of various gastro-retentive formulations. Now again this diagram will help you to understand how it works. First is the floating approach, right? You can see this red dosage form tablet we can say, and it floats on the fluid, gastric fluid. Second is bioadhesive. Our dosage form will stick on the wall of the stomach. Then third is high density approach, where dosage form will settle at this pyloric antrum. And expandable, this big means I will show you how it works. So yes, this slide will give us idea. The original dimensions of tablets like this small, but once it will come in contact with fluid, water, it will swell. And because of this swelling diameters, this swelling diameter will not, diameter means the dimensions, and they will not cross this pyloric space sphincter, right? You can see here. So these are the four approaches which we are going to discuss now. So low density approach is a floating drug delivery, means floating drug delivery. What are the requirements for floating drug delivery system? So here we have to think, we have to retain our dosage form in the stomach. This is first condition. Then second is useful for poorly water soluble or unstable in intestinal fluid. So poorly water soluble drug we can give through this floating drug delivery, and poorly water soluble means if we know the BCS classification. So class 2 BCS class 2 and class 4 drugs are of poor water solubility, have poor water solubility. Then the third thing we have to understand here is what the density of our dosage form should be less than the gastric fluid. This is the very important condition while designing this floating drug delivery. And so drug release slowly at desired rate from the system. So these are the requirements to prepare this floating drug delivery. Now again you can see this picture by which the concept will clear. So everything has given, only here one additional point has given, additional ring like structure you can see here. So that is called as modified shape system. Why we are modifying here? The shape is ring shape. So this ring shape will not cross this pyloric sphincter. Likewise also we can prepare the dosage form. So next point is uh, next point is swellable system. So how swellable system works? So this is also called as a plug system. So we know plug and socket. So plug is always on the socket, right? So this plug system, how it works? So here we have to increase the shape of our dosage form so that it will not cross the pyloric sphincter. So size of formulation should be more than pyloric sphincter. This is very important statement we have to consider at the time of swellable system design. So it should expand for gastric retention, should be collapse after lag time. So after it should expand for gastric retention, should be collapse after some lag time. So how much it swells, that determines the release rate. Okay. Sometimes what happen? It will swell and it will disintegrate very fastly. So we don't want that. Only that should retain in the gastric fluid for sufficient time, and it should not cross the pyloric sphincter. This is the main condition for swellable system. So you can see this picture, dry form and wet form of the tablet. Next is bio or mucoadhesive system. So here what we are doing, with the help of some polymers, that is bio or mucoadhesive polymers, for example chitosan, polyacrylic acid, carbapol, sodium alginate, HPMC, hydroxymethyl propyl cellulose, and this polystyramine. For with the help of these bio or mucoadhesive polymers, we are preparing our dosage form. This will stick to our mucus layer, stomach part, and they will release the drug. But here the important point is what? If our dosage form will not stick on the stomach part, then what will happen? This system will collapse, right? Because its effectiveness is depend on the mucoadhesive property. So therefore the dosage form must stick to the wall of the stomach, then only it will work, right? So last approach is high density approach. So high density means what? We have to increase density compared to our body stomach fluid. So 3 gram per centimeter cube, this is required, and for that purpose we are using different excipients to make it dense. So thank you very much for uh, thank you very much for listening this presentation carefully. and we will prepare more and more videos like this. Thank you.